Hello and welcome to Exercise Physiology Screencast. The focus is going to be on altitude. Okay, so if you have a look at specification here, key focus, we have to have a look at the effect of altitude on the cardiovascular and the respiratory systems. So particularly what we're looking at, as you'll have kind of gathered from the altitude screencast on gaseous exchange, we're really having a look at that impact on our ability to exchange oxygen as a gas from the alveoli to the blood and the blood to the muscles. That is the first key focus really of this screencast, is to say what is the process then of when you're at altitude, what happens negatively to prevent oxygen diffusing from the alveoli to the blood and the blood to the muscles. That's going to be our focus. We'll also have a look at kind of the fact that we have an elevated heart rate and ventilation. The next part of this is not going to be on this screen because we're looking at acclimatization. Okay, so talking about the reasons, okay, if all this negative stuff happens as a result of kind of being at altitude or exercising at altitude, okay, why do people do it? They do it because if you acclimatise to the altitude, you can then have some really good benefits. So we'll have a look at that separately. So let's start then. So if you have a look at the key thing we're focusing on here, we'll be looking at being able to explain the immediate effects of altitude of the cardiovascular and respiratory system. So a couple of things just to get us in on this. Okay, so if you're at altitude, so we looked at that kind of 2,400 metres as our kind of benchmark for someone who is at altitude. What happens? We start off with some basic things. So the first thing I'd ask you to look at, when you're at altitude, the conditions are considered something called hypoxic. Okay, so if it's hypoxic, what this means is there's a reduced partial pressure of oxygen in the atmospheric air. Now, if you think of this, I mean, a good way to remember this, if you think of hypoxic, you're high because you're at altitude, you're 2,400, maybe up to 5,000, 6,000 meters high. Okay, so you're high, hypoxic, and when you're in those conditions, the amount of oxygen or the partial pressure of oxygen in the air reduces. Now this, okay, straight away, the first thing that will happen, okay, as a result of this, is when you're in those conditions, you will have an increased breathing rate, or breathing frequency, and an increase in heart rate. Okay, those things directly go up when you try to exercise at those conditions. Now, once you've got those two bits, that's the introduction really to saying if you're at altitude, the conditions are called hypoxic, and then these are direct effects here on these two things. Now, from here, we now need to start thinking about the process of how we're going to get oxygen into our alveoli and therefore into our blood, therefore into our kind of muscles. So all of these things are impinged, they're reduced. So basically we have to look at the process of gaseous exchange now and look at how there is a decreased level of everything that we need in order to have a kind of efficient diffusion of oxygen into our working muscles. So first up then, the first thing we have to notice is a decrease in partial pressure of oxygen in the alveoli. Now of course that causes problems because if there's a lower partial pressure than would be normal at sea level in the alveoli, this reduces the kind of diffusion gradient between the alveoli and blood. Okay, so it reduces the oxygen diffusion gradient between the alveoli and blood. Now as a result of that, there is less oxygen diffused into the blood. Okay, so I'll put in red here. So what this means is, if you remember that the blood is hemoglobin, so there's less oxygen can then associate to hemoglobin to form oxyhemoglobin. Or if you want to stick to the kind of the pattern we used before, there is a reduction in the partial pressure of oxygen in the blood. Okay, so this is, of course, all of this stuff is in contrast to the stuff we looked at for gaseous exchange at sea level or just normal gaseous exchange, because we looked at, if you remember, this kind of GASP-DD process. If you think here, it's still here. So we've got the P, D, D, but if you have a look now, the partial pressures, there's a change because there's a decrease in the partial pressure of oxygen in the alveoli, which then means there's a reduction in the oxygen diffusion gradient between the alveoli and the blood. Now, of course, that means there is less oxygen diffused into the blood, and that means we have a reduction in the O2 hemoglobin association. So just to see that this is exactly the same as you did before for gaseous exchange, but the key difference is everything is reduced, okay, because of these hypoxic conditions where there's a reduction in the partial pressure of oxygen in the atmospheric air, which stops the process being efficient. So if we go on from there, now we're at the blood, we now think, and obviously we know that we have to now get the blood. Once we've got the oxygen from the alveoli to the blood, it's all been reduced. We now need to get it from the blood to the muscles. So then we go through the same process again. So we've got here. So due to a lower concentration of oxyhemoglobin, if you don't want to write that, you can just put the bit I'll put in brackets. The lower partial pressure of oxygen in the blood. This means that there is a reduction or decreased oxygen diffusion gradient between the blood and the muscles. Now this of course, means that there's a reduced oxygen diffusion into our working muscles because the gradient's been reduced. So what you can see here is if you look over, of course, we've got to do our blood to muscles, okay, partial pressures, diffusion gradient, diffusion. All of these are reduced, decreased, okay, so this means that eventually, when you think about this in real terms, if you do something at altitude, if anybody has done it, it's going to be a really kind of reduced process of getting oxygen from there to there and from there to there, okay, that is a problem. So what we have to do then is have a look at the actual effects of this. So the key effects, okay, that we have to look at. When you are at altitude, the immediate effects are that you have an increase in breathing frequency. I've talked about this here, so it's just as you get, you'll already have a mark for this, but just so you get an idea of what does this mean. Okay, there's an increase in breathing frequency, there's an increase in minute ventilation, and there is also an increase in heart rate. So anything to do with rates, okay, so kind of breathing or heart rate, it goes up. Now, what I would just say here, your heart rate's actually going up to try and maintain your cardiac output, because the key thing of having an increased breathing frequency, e.g. breathing more often per minute, more breaths per minute, an increase in breaths per kind of breath and minute, and then you go down to this, and a final bit is to say that the decrease, the thing that goes down, is because we're not getting oxygen into our kind of blood and working muscles. There's a decrease in blood volume, there's a decrease in stroke volume, and therefore there's a decrease in cardiac output. So that means we are really struggling, because of this gaseous exchange process, we're struggling to get oxygenated blood around to the working muscles, and this causes us problems. Now, after you've got those key bits there, the thing we're looking for next is to say, right, we've looked at the process on the respiratory system and gaseous exchange. We've gone through those bits. So we've got our PDD. So we go through that from there. Then, following that, we've got some effects. Anything to do with breathing, okay, or heart rates. Breathing rate or heart rate will increase, but anything to do with kind of volume or moving oxygen around in the blood, okay, stroke volume, cardiac output decreases. Now, what we have to know, the thing that's in the specification, is you have to be able to apply this to aerobic and anaerobic events. So if you're taking part in aerobic activities, what does it mean with regard to your performance? And I'm sure you can kind of guess that. So you've got it onto here. Aerobic performance will decrease, okay, because you can't get oxygen to the working muscles quick enough. So this will lead to a reduced intensity and duration, and you'll reach obla quicker. Now, on the flip side to that, I don't know if you could think of this, if you're doing something such as anaerobic activities such as shot put, okay, discus, javelin, those things now, you think of something really highly anaerobic, what do you think happens to them? Well, actually, your performance can increase because the air having a reduction in the partial pressure of oxygen, the air is thinner, so there's a reduced air resistance. So this can help things such as throwing, sprinting, jumping activities that are done anaerobically without the need to use oxygen. So all I'd say to you is kind of just making sure we've kind of got this stuff in. The process one here, we looked at kind of the ability of, we'll start off when you're at altitude, your translation really is hypoxic, okay, you need to know what that is, high, and then O is low. So there's a reduction in oxygen in the atmospheric air. Then we just talk about, right, what are those initial things that would happen? Then we talk about the process of a gas DD, but we only need to focus on PDD, because remember, gas is a thinking focus, and in this case, when we're talking about altitude, the only gas we're interested in is oxygen. Okay, so that might be a way of using these for questions in your Cornell notes. Okay, so please make sure you've had a good go at this, and remember, this is a direct continuation of the pre-altitude gaseous exchange screencast. Thank you.